Hello everyone, this is Ari from pantechelearning. So in previous session, we saw the core concept of ADC configuration and we have developed the code and we have seen the analog input for two channels. So we have used the two channels PA1 and PA2. So today we are going to get into another concept which is PWM. Okay, what is PWM? So the PWM is pulse width modulation. So you are going to send the pulse with the modulator modulation. So you are going to modulate the pulse width. Okay. So what is the pulse means? The on and off state. So we will see it in the next slide. Okay. So that is what we are going to see. So what is the use of the PWM? So where we will use it when it comes to the speed motor controlling the speed of the motor, or you are wanted to control the brightness of the light or LED, like those things. So we can control we are going to send the pulse with modulation. So we will control it by using the pulse. Okay. So before getting into the registers, we will see how it is working. Okay. So as I said, so the pulse is the on time plus off time is the single pulse. Okay. So now we have to know about duty cycle. So what is the duty cycle? So as per the duty cycle value, there is going to be a common output voltage is given to the pin. So whatever it is connected to a motor or a light. Okay. So this is a thing which is going to say the what is the percentage of voltage should be gone to the specified pin. Okay. So we will do it, if it is a duty cycle is 50 means the on time will be 50% and the off cycle will be 50%. When it comes to 75% of duty cycle means it is on time is 75 and you can see the off time is 25%. When you give a 25% as a duty cycle means it is going to be on time as an 25% and the off time is 75%. By giving this only, we are going to adjust the brightness of the LED. So if I give the duty cycle as a 25% means it is going to send the minimum voltage, which is ranging from we'll consider one voltage. Okay, so 0 to 3 volt or voltage range. So if it's 50 means it will be around 1.7. If you give duty cycle as 50% means then the LED will grow as per the voltage is sent to the LED. Okay, then 75 means it will be comes around 2.5 something. When we give 25 means it will comes around 1.1 or 0.7 like that voltage. So that is the voltage is going to be getting into the LED. So we have to configure the duty cycle and again we have to configure the auto read. So now we will elaborately see how it is working. Okay. So this is the output. Okay. So we have to give the two values. One is ARR, which where the value will auto reload. Then we have to set the CCR. So this is a value. This is a compare capture register. We have to set the value in this register. So I am going to set the value output in the initial set in the I value. Okay. So I am going to set the ideal line in the I position. Okay. So this line x-axis, y-axis represents the time and the x-axis represents the voltage. So when the timer starts, so PWM is going to work with the timer. So the PWM is one of the function in the timer. Okay. So the timer will start from 0. From time the time will be increasing as per the voltage increases. Okay. So I will specify some CRR value. Okay. I will give some duty cycle value. At that value, the cycle is going to tune off my LED by lowering the pulse. Then again it will travel in the low cycle in the logic 0. Then when it reaches the auto reload function, auto reload value, then it will get tuned on. Okay. So how does the voltage is controlled? How the brightness is controlled? So you can see it is the x-axis voltage and the y-axis is time, right? So if the time starts from 0 mean, then I will cut it I will give the CRR value as 5. Okay. So at the value of CRR of 5, the LED will get tuned off. So what is the voltage to the 5? So it will be minimum of 0.2 or 0.5 like that thing. Okay, or 0.25 will be the voltage value. So that is the voltage which is going to be a output for the LED. Then it will goes to the ARR. Then it will again get tuned on. When it reaches the AR function, again it's going to tune on and it's going to go to the CRR value. So the CRR value is going to say at which duty cycle I have to tune off it, till which voltage I have to make it. So we will adjust the brightness by giving the value in the CRR. If I give a CRR value as an 100 means, then the corresponding value to the x-axis will be the voltage. So if I give the 100 means, the consider we will take for example we will take for 100, the corresponding voltage is 2.0 volt. Okay, so the LED will grow at the voltage of 2.0 volt only. So when I given a maximum value of ARR for the CRR, then my LED will grow on the maximum voltage. So this is how we are controlling the brightness and the speed of the motor by using the pulse width modulation. Okay. So next we have to know. Now we have seen what is PWM and how it is working. So now we have to know what are the things we have to do for configuring the PWM. Okay. So for that we will get into that. So before that you can now convert this masterclass into an internship. So 1 month internship on embedded system. The fees is 1,200 guys and the discount price is 509. So use this code ESMC1 to get the offer internship fees of 690. So the internship is going to add the lots of topic guys and going to be explained in a detailed manner, and lots of hands-on projects is going to be added in the internship, and we have a pipeline of like CAN protocols, SIN protocols, all these things. So guys, use this opportunity and you will get lots of benefits by registering for this internship. So now we will see what are the benefits. So you will get 30 days of live session recordings. So that recordings video will be accessible for you 90 days. So if you are trying any concepts, core concepts or communications means, you can make use my video as a reference. Okay. So for that purpose, it will very much advantage, and you will see lots of hands-on practice on embedded projects, and we will create lots of projects, and you will get 30 days of downloadable presentations. And the main advantage is we will have a one-to-one mentor live for 6 sessions. So already one session is over guys. So the batch 2 is going on. So coming Saturday you will have a one-to-one live session. So guys, use this opportunity to upskill yourself and register for the internship. So you can interact with me directly one-to-one in every Saturday class, and you can ask the questions that I will try to clear in the same class, or if it is so complicated then I will clear it on the upcoming classes. Okay, then the internship certificate will be provided after registering, and we will provide a e-certificate, 2 e-certificates, one is for participation and another one is for course completion. Okay, so guys, use this opportunity. So use this registration fees is 1,200. So use this coupon code ESMC1 to get the discount of 509. So the discount fees is 691 at the final. So the registration link will be given in the chat box guys. So you click this link right now to go and registration. So use this internship to upskill yourself. Okay. Okay, thank you. So guys, next we will get into the topic. So before going to that, we have to set the prescaler for timer, right? Because the PWM is one of the function in the timer. So the PWM is going to use the T clock frequency, timer frequency only. So we have to give the timer frequency, right? So I'm going to generate the timer frequency. So my T clock is 16 megahertz. Why? Because wait, I'll show you. So we are going to use the internal clock, so which is HSI. It is a 16 megahertz of frequency. So we don't need to configure the system clock configuration, because by default it is going to be a configure the internal clock HSC, which is 16 megahertz. And I'm going to not divide the prescape AHB prescaler and these values. So our timer 2 is in the P clock 1. So you can see APB1 bus. So we are getting a 16 megahertz. Okay. So we are using the internal crystal directly. So that is the reason we are our frequency of the P clock is 16 megahertz. Okay. So now what we want is I need a 10 kilohertz of frequency for timer. So what mean by 10 kilohertz frequency? So 1 kilohertz frequency means 1000 hertz, 1000 frequency per second. Okay, 1000 clock pulse per second. So if I getting a 10 kilowatts of frequency means 10,000 clock cycles per second. So I'm going to get this because while we are doing a precise timer, we have used 1 kilowatts because the for 1 kilowatts means it is going to be a 1000 cycles for it's going to be perform 1000 cycles per second. So we are used the millisecond delay there. So here we are getting is 10 kilowatts. So it is going to be 10,000 cycles per second. So for controlling the brightness, I need a minute thing. So for that, I am using a 10,000 kilohertz. Okay. So our main frequency is 16 megahertz, and our the needed frequency is 10,000 kilohertz, 10 kilohertz. Okay. So finally, we will get a value of 1600. So prescaler will always add the 1 to it. So microcontroller will defaultly add the 1 to it. So we have to initialize the value by minus 1 by minus 1. So final value is 1599. So this is the value we are going to give for the prescaler for T clock. Okay. So we are getting is 10 kilowatts of frequency. So what are the steps for configuring PWM? So first we have to enable the clock for a timer, and what is the timer we are configuring, and we have to configure the GPIO pin, and we have to select the mode and alternate function for the pin, and we have to select the channel as an output. So we are going to give output, right? We are going to now we are going to develop the project for controlling the brightness of the LED. Okay. So we are going to control the brightness of the LED. So we are going to select the we have to select the channel as an output. Then we have to set the polarity. So what is the polarity? So this is the polarity. So if I give a by polarity only, I can say that what is the initial step for the pin. So if I give the polarity as 1 means it is going to start in the logic 1 state, and it is going to tune off as per the CRR's value. If I give polarity as 0 means it is going to start from the logic 0, and it will be look like you will get an first you will get a logic 0 line, then as per the CRR it will get to I, and it will get tuned on, and as per the ARR again it get to the get tuned off. So we are going to use this polarity 1. So this is what polarity is. So the polarity will say where the line starts. Okay. Where the line would be in the logic 1 or the logic 0. Okay. So we will give the polarity. Then we will set the PWM mode. Then we have to set the prescaler value. I have already shown you how to derive the prescaler value. So we are going to use this 10 kilohertz of frequency, and we have to give the auto reload function. At which state we have to tune on the LED again. Okay. Then we have to give the duty cycle. So this will say you have to tune off. Okay. Then we will enable the preloader, and we will enable the auto reload function. Then we will enable the channels. Okay. And finally we have to enable the timer for counter or timer, both are same. Okay. So these are the steps we are going to do for developing the code. Okay. So guys, now we will get into the registers and we will develop the code. Okay. So first we will open the KEIL ID. So go to the project. Now we have to select the port. So I am using this STM32 F407. So I am using this Discovery 4 VG. Okay. So then we have to go the sensor scope and startup file. Now we will add the .c file. PW. First, what we have to do? First, we have to include the startup file, right? So include. Then we will create a main function. Okay. So what are the things we have to do? So first we have to enable the clock for the GPIO and the time. So first we have to know, we have to decide which timer we are using and what is the channel we are going to use. Okay. So for that you have to go to the, I'm going to the data sheet. So in my data sheet, guys, I'm using the board of discovery board. So the PD of the pin, the port D, in that pin 15 as a PD15 is connected to the inbuilt LED in my board. Okay. So I will see the PD of 15. Okay. So when I see this pin is defaultly we have an inbuilt LED in the my board, discovery board. Okay. So what is the timer here? Presents it as a timer 4 and the channel 4. So I have to configure the timer 4 and channel 4. Okay. So we have to first, it is in the D port, right? So first go to the RCC register of AHB1 ENR, and now we have to send the logic 1 to the port D. So because we are configuring this pin PD of 15. So I'm going to send the logic 1 to the third bit. Okay. So I will send, first I will create the function CC of HP left shift of 3. So this will enable the clock for GPIO port D. Okay. Then we have to enable the clock for timer, right? So it is in the APB1 bus. So go to the APB1 bus. You can see we have a timer 4 in the second bit. So we will send the logic 1 to the second bit to tune on the clock for timer in APB1 register. So RCC of 1 left shift of, in which bit is it? It is in the second bit. Okay. So we will left shift the logic 1 to the second bit. Now we have enabled the clock for the both the GPIO and the time. Then next what we have to do? We have to set the moder and alternate function. Okay. So go to the GPIOs. So in GPIO moder we have to select the alternate function for the pin 15. Okay, because we are configuring this PD 15th pin. Okay. So I have to send logic 1 to the 31st position. So simply I will left shift the 2 to the 30th bit. So this will set the logic 1 in the 31. Okay. Now we will so this will set my alternate function. Then we have to select the alternate function, right? So go to the, again go to the GPIO. And then go to the alternate function. So we are using this last 15th pin. So we have to configure in the I register. Okay. So in I register we have a timer 4 in alternate function 2. Okay. So go to the, in this we have a value of, we have to send logic 1 to the 29th bit. So we can even, I'm going to send simply left shift the 2 to the 28th bit. So the logic 1 will be get settled in this 29th bit. Okay. So in, I will, now we will create the format function. Okay. Left shift of 28. So this will set my alternate function. Okay. Then next what we have to do? We have to select the channel as an output. Now we will get into the timer registers. Okay. So where you will select the time output mode. So go to the timer registers from 2 to 5. So in this you have to go to the CCMR. So wait. So we have a two compare capture mode register. So one is for first compare capture mode register. One is for channel 1 and channel 2. So we are going to configure. We will configure. We have 4 channels. So for if you want to configure the channel 1 and 2 means you have to use the CCMR1. So I am going to configure this channel 4. So I have to go to the CCMR2. So we have a CCMR2. In this you can see we have a channel 4 in the 8th to 9th bit. So we have to send logic 0 to the 8th and 9th bit to select the output mode. Okay. So first we will send it. So we can, it is in the reset state. So we will simply first timer off. So this will set this will set to 0, logic 0 in these all the bits in CCMR2. So I have to set the 8th and 9th bit as a 0 0. So now it has selected as a reset thing. So we have selected the channel 4 as an output. Okay. Okay. Next what we have to do? Next is we have to select the polarity, right? So for selecting the polarity, we have to go to the enable register, compare capture enable register. Okay. So you can see we have a bit in 13th bit to enable the polarity. So you can have a reference here. So if you send a 0 means it is active high. That means the initial state is high. When if you give logic 1 means the initial state is low. So I am going to send logic 0 to the, this is for channel 1. So I have to send logic 0 to the channel 4 polarity here. Okay. So now we will send this to the 13th bit. Okay. So timer. So to which bit we have to send it to the 13th bit, because the 13th bit is as a channel 4 polarity bit. Okay. So now we have selected the polarity as active I. So the initial state is I. Okay. Next what we have to do? Next we have to select the PWM mode. Okay. So for that go to the CCMR. So the CCMR2 we have to configure this CCMR2 because our channel is we are using is 4th channel. So for first 2 channels the CCMR1, for 3 and 4th channel the CCMR2. So when you see the CCMR2 register, it will be not elaborated. So you have to check with CCMR1. Okay. So go to the CCMR1. So you can see we have a 14th and we have a dedicated bit 14 and from 12 to 13 for the selecting the output mode. Okay. So how we will select the output mode? So we will see this. So we have you can see if you want to select the PWM mode 1 means you have to send logic 1 to the 6th and 5th bit and logic 0 in the 4th bit. So likewise, if you want to see, so we have for channel 4 we have a dedicated bit of 12, 13, 14. So we have to set the logic 1 in the 14, 13 and logic 0 in the 12th to configure the pin as a PWM mode. So we have to refer to set the value in the CCMR2, we have to refer the CCMR once because there will be detailed reference. So You have to check this value and you have to give the value in the CCMR2. So now we will give the value logic 1 to the 14th and 13th and logic 0 to the 12th bit. Okay. Okay. Now, so give timer 2 to CCMR. On left shift of 13 and 14 because it will select the PWM. Okay. So now we have selected the PWM output mode. Next we have to give the pre-scalars value, right? So we have a dedicated pre-scalar bit. We have a PSC is a pre-scalar. So we will set the value in the pre-scalar. Okay. So what is the value we are going to set? We have already derived the value from the formula, which is 1599. Okay. So sorry. See, we are configuring as timer 4. Okay. Okay. So timer 4 of pre-scalar is equal to 1599. So this is the value for my pre-scalar. Okay. So what is the value? It is 10 kilohertz. So 10,000 cycles per second. Next thing what we have to do, we have to give the auto reload value. So for that, we are going to define the period and as defined. Period of 200 and I am going to define a duty cycle. 100. Okay. So what I am going to do is, so we have an auto reload register. So we have an auto reload register. So as per the timer, we can configure if the timer 2 and 4 means we can configure all the bits. So it is a 32-bit timers, and we have a 16-bit timers. So as per the function, we can give it. So timer of so this is done to we will change the values of that to do some brightness changes. Okay. So then next thing we have to give is duty cycles value, right? So where you will give the duty cycle value. So we are configuring the channel 4. So we have to go to the so compare capture register 4. Okay. So in this we have to give the duty cycles value. Okay. Okay. We have a 4 compare capture registers. So each for each channels. Okay. So we are configuring channel 4. So now we have given the duty cycles value. Then next step we have to do is we have to enable the preloader and auto reload function. Okay. So to enable the preloader, we have to go to the CCMR2. Go to the CCMR2. So you can see we have a preload enable bit in the 11th bit. So it doesn't go to the CCMR2, it is in the CCMR1. Okay. So you have to send logic 1 to the 11th bit to enable the preloader. So preload. So you can see we have an output compare 4th channel preload here. So you have to send the logic 1 to this 11th bit. Okay. So now we will. So this will enable my preload. Then we have to enable the auto reload function. So we have to see it in the control register 1. So in control register 1, we have a 7th bit as an auto reload enable bit. So we have to send logic 1 to this 7th bit. So this will enable my auto reload function. Then what is the step? Next step we have to do? We have to enable the channel. So we have to enable the channel force output. Okay. For that we have to go to the registers. In that compare capture enable register, we have to go to the CCER. In this you can see we have an compare capture output enable. So we have to send the logic 1 to this 12th bit. So you can refer to this 0th bit. So it is for channel 1. So 12th bit is for channel 4. So if you send 1 means the output capture signal is output on the corresponding output pin. So we have to send logic 1 to the 12th bit. So 12th bit. This is a so for a reference we can see the channel 1 enable. So for that reason only we are seeing this. Okay. Okay. So we will send logic 1 to the enable bit in the 12th position. Okay. So you can see here we have an enable polarity here. Okay. So we will send the timer for CCR on left shift of 12. Then finally we have to enable the counter. So for that you have to go to the control register 1. So in this we have a 0th bit as a counter enable. So we have to send the logic 1 to this 0th bit. So this will enable my counter. Okay. So before this we have to create a while. Now we will compile this. So we have no errors. Now we will import this code into the board. Okay. So before that we have to select the output. Go to the debugger, select the stealing debugger. Okay. Okay. So now we will import the code. Okay. Okay. Now wait a second. I will connect the LED there. So guys, you can see the LED is at the particular brightness. Okay. So now we will reduce the brightness. Okay, by reducing the duty cycle 250. Okay. So now you can see the brightness is reduced. Okay. So it is due to the camera, it is looks like blinking for you guys. Okay. So next thing we will create a we will adjust the brightness. We will start the brightness from 0 to the final of duty cycle. Okay. So now what I am going to do is off. So I will instead of here, so duty cycle duty, I will change it to the I. Okay. So then we will add some software delay. Okay. So guys, now what it's going to do is it is going to start the duty cycle percentage from 1 to 100. Okay. So we will so the delay is 2i. So we will reduce some delay. Okay. So now you can see the LED is so it is growing from 0 brightness to the 100 percentage of brightness. Okay. So you can see this inbuilt LED also. So you can see it is getting brighter. So as per the code, the duty cycle is from it is starting from 0 to 100 percentage. So the LED is getting brighter by brighter. So likewise, we can control the speed motor control also. Okay. So this is the reason why we are using the PWM. Okay. So you can see now the brightness is increasing without a flickering. Okay. So this is how we will control the brightness and the motor speed of the LED. Okay. So even we can try. So you can see the LED is getting step by step, it is getting brighter. Okay. So this is how we will configure the PWM. Okay guys. Okay. Thank you. We will meet on next session.